So that's our portfolio locus. As we vary the proportions in the two stocks, we trace out this line. Now, this is a rather special example because what's the correlation in our example here? The correlation of A and B, we know correlation is covariance divided by standard deviation of X times standard deviation of Y. What's the correlation here? It's minus 1.25 divided by 1.12 times 1.12, but we know 1.12 squared is what? 1.25, so the correlation here is -1. So just like in our example with the coins, where we had the possibility of getting rid of all the risk if rho is -1, we're able to do the same thing here because correlation is -1. If correlation wasn't -1, what do you think our portfolio locus would look like? Suppose rho was 0. Instead of this line like this, what do you think we're going to get? Okay, so rho equals 0. Can you do better by diversifying with rho equals 0? If you think back to our coins example, could you do better with two stocks if you had independent returns? What happened when we had a tail and a head? Then we were at the mean, so what happened to the risk? Went down. If we've got A and B with rho equals 0, where's it going to be? Can we get to the axis? Can we get rid of all risk with just 2? No. But can we get rid of some risk? Yeah, we're going to get the accidental cancelling out, just like we had with the coins. So rho equals 0, we're going to have something like that. If we have minus 0.6, where are we going to be? Are we going to be closer to the axis or farther away? We're going to be closer, because if minus 0.6, what do we get? That means they tend to move opposite directions. So what happens to the variance if we have them moving in opposite directions? Get smaller, the variance. So this might be rho equals minus 0.6. We know that if we've got minus 1, we can go all the way to the axis. What about plus 0.5 correlation? What would that be? Yeah, be farther away from the axis. So it would be something like this. Rho equals plus 1 would be what? The vertical line between the two. So this would be rho equals plus 1. So as rho goes down, we get closer to the axis, we get more benefit from diversification. Any questions on that? So now we've got the portfolio locus. How do we choose the optimal portfolio? If we're choosing the optimal portfolio, so we're going to put the indifference curves together with the portfolio locus. what are we going to get? So we have some portfolio locus like that. The best portfolio for you is going to be where? Well, it depends on what. What's it going to be determined by? Your risk aversion. So if you had regular kind, you would be somewhere like that. If you were more risk averse, you would have what kind of indifference curves? Steeper. So which direction would you move? Left. You'd be moving down here. You'd have a lower mean and a lower standard deviation. So that's the optimal portfolio. And that's telling us how much A and how much B you have. Okay, so here we might be what? What do you think that would be? How much in B and how much in A? So maybe 70 in B, 30% in A, something like that. So now we've got a theory of demand. We know where your risk aversion is represented in these indifference curves. We can tell how much A and how much B you're going to choose in your portfolio. So this is a first step. What's the problem here, though? How many stocks are there in the world? Thousands, right? Thousands of stocks. So it's nice to be able to talk about two, but we need to talk about thousands. Or in general, we need to talk about N, yes. So let's look at an N stock portfolio. So now what we're going to get is sort of just 2 points and the line between them. We're going to have N points. These are the N stocks. And then we can mix any two of them. We get the same kinds of lines, and we can mix many of them. And what we get is a big mess. But we can simplify things, because would you ever hold a portfolio like that? Can you do better than that? Same risk, what can you get? A higher return. So what we're going to argue is that what you're actually interested in is the northwest frontier of all these possibilities, and that's the portfolio efficiency locus. And then once we've got that, we know that you're going to choose some point on there, and that's a particular combination of all these N stocks. So you might have 3% in stock 1, 2% in stock 2, 2.6% in stock 3, and so on for all the N stocks. So we can develop the same kind of theory for many more stocks than 2 and come up with demand for stocks. Any questions about that?